Professor Suresh?
Sir, it's still loading, sir.
Okay.
Yeah, now it's visible, sir. You may go into presentation mode.
Sure. All right, now let's go through the demo. So all of you can see my screen with the Visual Studio Code. So this session is being recorded, right? You can't see the Visual Studio screen. So let me share. It's window. Yeah, you should see the screen now. All right. Now it is being recorded so that you can use this video to complete your assignment, right? So necessary libraries that we are importing. So this is the Visual Studio with Jupyter Notebook plugin and Python runtime installed through the Visual Studio extensions. I'm sure you guys can do that. If any one of you have problems in installing, write back to me. I'll share step-by-step procedure, and I'm sure there are lots of videos as well, but I'd be happy to help, right? Then this part imports the necessary libraries. So I've just executed this. So it uses Panda, NumPy, MATLAB, Matplotlib, Seaborn for the gain plotting, and of course SK scikit-learning, and then the image processing. And then in the next code segment cell, I'm configuring certain parameters, and I'm also loading the data set. The Ames.csv I've shared with you guys, and I kept that in the same folder. You can see it here. You can open the data set using any of the data wranglers, freely available tools, and you can see yourself and do some analysis using those plugins of how many parameters, what's the value, variance, blah, 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 all that stuff, right? It's connecting to the kernel Python runtime. It'll take few probably seconds to minutes. Let's give it some time. It's now loading the data frame. All right, it's taking too much of time. Let's go back to our code. And then it's, so this cell has 4 to 5 assignment questions. For example, it implemented. It prints the total number of columns or features. It also prints the total number of samples. It also identifies any rows that have missed values, be it categorical, be it empirical. It also identifies categorical, not empirical, categorical and numeric values or columns. And it plots, there's no plot here. And then it encodes those categorical values. So let's execute this. So it is executing. Let's look at what it has printed. So it says Ames housing data set columns are, these are the columns, totally 80 columns. And it has 2,930 rows of data. And it has these columns that are numeric values, continuous values. And it has these columns that are categorical values. And it has no column that has no value. That means all the columns have the values. numeric columns, but it has two categorical columns that have missing values, which are, some type of the dwelling and then some miscellaneous feature. And it has filled in missing columns with values. If it is a categorical value, we are filling with missing. If it is a continuous value, easiest is fill it with mean value. You would have computed the mean anyway, right? And then it has scaled and transformed, right? So found the total number of columns as well. It has scaled and transformed the entire data set before the training, right? So 6 to 7, I think, questions are addressed. Now let us apply PCA without any reduction. So that means we treat all the input features as PCAs, and then now try to plot the high spread variances or identify what is the variance, explain the variance of each feature, and maybe put a cutoff of 90% is highest, top 90% highest variant features having the variance. We will take them, consider them as the principal features, and will that be lesser number than the 80? Let's run and see. So it's running. It's a lot of computing, a lot of crunching the data. And it takes a lot of time because right now, because there is a Google recording going on, Google conference going on, and then there is a presentation slide, and then obviously this training. Yeah, see, you can see the load or the time of computation when your processor is doing multiple tasks, one related to Google Meet, and the other part of the Google Meet recording, and then the presentation, and then the training. In fact, it took less than 10 seconds when I ran without Google Meet. So now, anyway, let's look at it. So it has computed the variance for each feature. So even though it shows 300, essentially we have up to 80 fields. After this, after here, right? After 80 here, then it is the same value. It has no meaning. It just, because of the scale of the graph that I chose, width of the graph that I chose, it's plotting the values, right? So you can see here the highest variance, starting with few factors to at around 50. Then there is a drastic change. It's called the elbow effect here, right? Where it drops to, the drop rate is far higher than the other places, or far less, and that is your threshold points essentially. And then this is per feature, and if you plot cumulative variances, summing up the variances of each variable, each column, then that is where you see the elbow effect here, right? Till then it raises faster, like exponential, and then slowly it plateaus out, right? Like your E curve, exponential curve. So probably if you take a 90% of that value of the total for which number of parameters up to first to 55, that's what it says, right? 55, those features become your principal components. So from a feature set of 80 parameters or features or dimensions, we, using PCA, are able to deduce that if we use 55 features, then we still be able to have efficient prediction or 55 dimensions, efficient prediction and efficiency of the model. Thereby, we have reduced the cost of training, essentially the duration, etc., etc., etc. Right? Now let's compute the PCAs for those 55 dimensions, which is nothing but your optimal components. It'll take another couple of minutes. And plot a heat map, right? Essentially so you have 55 components, principal components on x-axis, and you have 55 principal components on the y-axis. So it's a mix and match, right? Permutations and combinations. For the first principal component against the rest of 54 components, what is the correlation, the highest to lowest, right? So you are essentially, it has to come down to 0. That's how we have picked up at the 55th component. This is the correlation. So they are highly uncorrelated. If they are correlated, it would be 0, right? Now, let's pick top 5 principal components and plot a pair plot, meaning pair them. Just like the above, 55 versus 55, let's plot 5 versus 5. So what are we doing here? So we are using the principal components 5, and then we are transforming it, and then we are converting into data frame for plotting, then some background image, and then we are pair plotting it, and then adding, yeah. So you can see there are 5 on the y-axis, 5 principal components, and 5 on the x-axis. So if you take first component versus the 5th component, this is essentially the data distribution in those 2 dimensions against each. It's just to see, these are the patterns that are useful as you get into more machine learning mathematics. Essentially, it is a statistical analysis and then deriving the mathematics surrounding the statistical analysis and identifying essentially the pattern analysis using the statistics and mathematics. And then you can generate a PDF. I'm gonna save the time. You can generate a PDF of the entire code and image, which I have done already here. You can see this, and I'm going to open that for you guys. And this is what I would expect you guys to submit. Right? It'll create your code, your output, as you can see, your plots, right? So let's go back. Oh, PowerPoint is gone. Okay. So I'm back to PowerPoint, but it's taking time to show the PowerPoint. Let me go back to the PowerPoint. It's entire screen. No, this one. Okay. All right. Any questions? Okay, let me ask you this. Any of you have completed the implementation? Can you please type it in the chat if you have completed? None of you have completed. Would you be willing to complete by tomorrow night? We'll go through the code again in detail tomorrow. My intent of today is to give you the theoretical overview and run through the demo and give a bit of mathematical background behind the algorithm. Tomorrow we'll spend probably 1 hour completely only in the code, where if you are interested, you can code online. It's a lot of code, but at least you will complete the remaining code tomorrow online while we are going through the session. So guys, can you tell me or message if you have completed this project? No, none of you have completed. All right, Navaneet has completed. So would you like to share and demo your output if you have completed, if it is running here through the Google Meet? Would you be willing? Navneet, can you go on mute, please? You have submitted in the classroom. Okay. Excellent. Anyone else has completed the project? Excellent. Great job. Keep it up, Navneet. Was there anything that you felt hard? How did you feel implementing this project and applying the PCA for this particular project? Anything that you want to share quickly? Navneet? Okay. Okay, Vishnu, you've complete. Oh, okay. You're Vishnu, but your name says Navneet. Okay, Vishnu. So can you share your experience, how you felt, what's your learning? Okay, you joined through Navneet's phone. I understood. Would you like to speak your experience of implementing? What did you learn? All right. I'm not sure if whether he's on mute or he's not able to speak. Anyone else want to speak? Want to share their experience or ask questions on how to complete the project?
Guys, you can unmute yourself and you can ask if you have any doubts.
Girls and boys, any questions? No questions. All right. So I have one question, guys. What is next week's topic? What is next week's topic? Okay. So usually students are this muted even in the classes, Professor Suresh? Anyways, looks like, yeah, go ahead. All right. Okay. Navneet or Vishnu. That's correct. Vishnu says next week's topic is linear regression. That's correct. So tomorrow, midnight, 11:59 is the last deadline for submission, guys. tomorrow 1 hour. Please come back. I mean, tomorrow let's start on time, 10:30. I will dedicate the entire time for first 30 minutes for Q&A, or maybe let's do it. First 30 minutes to 45 minutes to walk through the code line by line. And then the next is Q&A. I'd like all of you to complete the code tomorrow along with the session. And if there is any remaining thing, generating the PDF you can do after this session and upload to the assignment in the classroom before 11:59 midnight tomorrow. But it is important that you guys really try coding it. The only way to learn algorithms is to code. You would feel you've learned the algorithm when somebody teaches in a class, theoretically. But that is not enough when you get into the real world of business. You start getting lots of questions. Oh, I understood this way, whether it was a matrix, it was a vector, or it was a scalar. If it is a matrix, what is the processing? If it is a scalar, what is the processing? All those you will face only when you start coding, right? And if you don't do that now, whether in interviews, campus interviews, special selections, or whether when you start your job in training, obviously you would have to spend more effort then. And then you probably may be behind the others who would have already done that. So anyway, you have to do it. Why don't you do it now? So please code these algorithms. I would also upload my code tomorrow morning into the class, online class, so that you can compare. But I would like to see all of you guys complete and upload code, put the code, run it, and then submit to the assignment online. All right. So last time, if there is anyone has any question, I definitely would love to address. If not, we can wrap up the class or session. All right, looks like there are no further questions, and Professor Suresh, probably,
Sir.
if you want to add
Yeah.
anything.
That's it, sir. Like I actually they might have questions like when they start practicing, if I'm sure. Yes, sir. So for time being, like nothing, sir, from mine.
Okay, excellent. So I think before the internals, this is the last class. I think we would have 1 to 2 weeks of internal break starting Monday, I
Yes, sir.
believe.
Yes, sir.
Probably would be meeting back on 22nd or 23rd or 25th. Please look
Yes.
at the schedule that is published on the FCH, on the Google Classroom online. One student has mentioned in the survey that please help us understand the schedule. Okay. Pakkasila Sunil Kumar Reddy, please go ahead. You have a question. Sunil? You may be speaking on mute. Would you like to unmute? Sunil Kumar Reddy, you have raised hand. Would you like to ask some question? Sunil?
I guess it might be by mistake, sir.
Okay, no worries, no worries. No worries. Excellent then. So I wish you all the best for your internal exams, particularly best meaning put effort, understand the respective chapters, and if you have questions, reach out to your friends, fellow students, or to the lecturers. But focus on completing this assignment by tomorrow, guys. Have a great weekend ahead, and we'll We'll meet up tomorrow, but please be on time. 10:30 means 10:30, guys. I joined the session at 9. I opened the meet at 9:15. One thing that I would request you guys is, which would be helpful for all of you, punctuality. Nothing beats punctuality. That would be one of the best assets. And I would say the first principal component of your life space that you should have, without any negotiation. So build that discipline, be prompt, be on time. So see all of you tomorrow, 10:30, guys. Have a great Saturday ahead. Bye-bye. Signing off.
Thank you so much, sir. Thank you. Bye, sir.
Bye-bye.